Hello guys, welcome back to our channel. Today we're going to show you how to measure volt and ohm with the Arduino Uno.
As you've seen in our last video, the analog pins can read out voltages from 0 to 5 volts, but that range is a bit small. That's why we are going to use voltage dividers. They are one of the most widespread electronics circuits fragments. But first of all, what are voltage dividers? To put it very simple, a voltage divider is a circuit that, given a certain voltage input, produces a predictable fraction of the input voltage as the output voltage. Here you can see the simplest voltage divider. Here we power this circuit with 4 volts and we get 2 volts out. This is due to the fact that the resistors have the same value.
This can be proved with this formula. V out divided by V in equals R2 divided by R1 plus R2. By adding values to the formula, it looks like this. 2 volts divided by 4 volts equals 47 ohm divided by 47 ohm plus 47 ohm. By calculating that, both sides should be the same.
With this formula, we can figure out the value for one resistor so that we can input a voltage till, for example, 35 volts and the output stays under 5 volts, so it's perfectly for our Arduino. The formula is R1 equals R2 times V in minus V out divided by V out. And if we add values to the formula and calculate for R2 100 kilo ohm, we get for R1 600 kilo ohm.
We are increasing the voltage till nearly 32 volts, and you can see the input on the left side and the output on the right side. By nearly 32 volts on the input, the output is about 4.4 volts. As soon as you draw current from the output voltage collapses. Here you can see the voltage divider without the load, and here and with a LED as the load. But keep in mind, the Arduino only draws a very small current, so it doesn't interfere the output voltage.
Here you can see the code. First off, we are declaring some variables, which functions I'm gonna explain later in the code. Then, in void setup, we set the pin mode for A5 as an input, and we begin the serial communication with a baud rate of 9600. In void loop, we read out analog pin A5 and save it in the variable readout0. Then we divide this variable by this value, which you have to search your own. You have to attach your voltage divider with the output to pin A5 and ground to ground of the Arduino and supply it with a voltage, for example 10 volts. And then you open the serial monitor and see what the analog read function reads if you supply 10 volts to this pin. Then you divide this value you got by 10 volts. If you put 10 volts in, I got 312. I divided it by 10 and then I got this value. And here I divide the readout by this value, so we get the actual value. You have to do this because the voltage divider spits out not the actual voltage, it steps it down. Then we print this readout and set a little delay.
Here you can see the voltage divider connected to the Arduino. On the multimeter you can see the voltage we're putting in, and on the right side you can see the voltage values the Arduino spits out. But always keep in mind to connect the ground of the power supply to the ground of the Arduino.
Here you can see the code with which you can measure resistance. First we declare some variables again, but now the value you got variable is 1023 divided by 5. Why only 5? Because the Arduino just gives out 5 volts. Here we declare some variables for the formula to calculate one resistor in a voltage divider. We have chosen a 1 kilo ohm resistor as R2. The voltage input is 5, and we are going to read out the voltage output and calculate R1, which is the resistor we want to measure. So in void setup again we use the pin mode function to say that A5 is an input and begin the serial communication. In void loop we read out pin A5 again, and this time we also divide it by this variable and save it as Vout. And here we basically calculate R1 with the formula R2 times Vin minus Vout divided by Vout. Then we print R1 and delay 100 milliseconds.
Here you can see an example with the fixed 1 kilo ohm resistor connected with one side to ground and with the other side to pin A5 and to one side of the resistor we want to measure, and the other side of this resistor to plus 5 volts. The resistor we are measuring has 470 ohm and the Arduino measures 469 ohm. That's absolutely perfect.
Here you can see the final version of the resistor tester. We added 3 7-segment displays and an LED to indicate if it's either in the kilo ohm region or in the ohm region. We also added an on-off switch. And here we inserted the 470 ohms resistor, and it also measured around 470 ohms.
We hope you enjoyed watching us. Please like, share and subscribe. That would help us a lot. And bye!